Okay, this video is about probability. You have been doing probability for a while. I'm sure you did it the last several years too. So we're just going to do a refresher over probability. This is something you want to memorize. The probability of something is the number of ways an event can occur and the number of possible outcomes. That's kind of confusing to me. I like to say probability is the number of favorable outcomes over the number of possible outcomes. And that'll make more sense as we do some examples. So I just want you to remember probability is the number of favorable outcomes over the number of possible outcomes. So if you roll a die, what is the probability of rolling a 4? Well, the probability of a 4, it can only happen once. That's the number of favorable things. And the number of possible outcomes is 6 because there are 6 different sides to the die. So that's the number of possible outcomes, so that goes on the bottom. But the favorable outcomes of rolling a 4 happens once, so it's 1 out of 6. If you roll a die, what's the probability of rolling a number less than 4? Okay, so the number of favorable outcomes would be 1, 2, and 3. But the number of possible outcomes is still 6. 3 over 6 reduces to 1 over 2. Okay. If you pick from a bag that contains 5 blue marbles, 2 green marbles, and 3 red marbles, what's the probability of picking a red marble? So we need to add up all the possibilities. So 5 plus 2 plus 3 is 10. So that's a number of possible outcomes. The favorable ones is picking a red marble, and there's 3 chances to pick a red marble, so it's 3 out of 10. Okay, and then so the island goes into the probability of A and B. So we're needing 2 things to happen, and that's when we multiply. So we'll talk about that as well. Okay. This one's pretty tricky, and I've seen it a couple times, and I didn't know how to do it, so I had to look at the answer. So we'll talk about it, and I'll show you the answer explanation of how to do it. So it talks about Carlos throws paintballs at a target his uncle made for him. The target is a square board with a circle with a 9-inch radius drawn on it, as shown below. Carlos is able to hit the board every time, but his hits are entirely random. What is the approximate probability that his next shot at the target will hit outside the circle? So basically you have to find the area of the square and the area of the circle and subtract them from each other. So the area of the square would be 18 times 18, because one side of the square is 18, the other side is 18, and that comes out to be 324. Then you find the area of the circle, which they put the formula on there, and that comes out to be 254. So then you subtract them from each other. And this is our area outside of the circle. So then we have to take the area outside of the circle and divide it by the whole area of the square, and we get 0.215. So that's how you do those ones. So you take the area of the square minus the area of the circle, we get what's left over, and then divide it by the area of the square. It's kind of tricky. Didn't know how to do that one. Okay. Monica has a jewelry box of earrings. The box contains 4 pairs of plain gold earrings, 11 pairs of plain gold earrings with diamonds, 3 pairs of plain silver earrings, and 6 pairs of silver earrings with diamonds. If she picks a pair of earrings at random from the box, what is the probability that she picks a pair with diamonds? So I like to find the bottom number first. I'm going to add up all of the earrings to see how many we're working with, how many possible outcomes are the bottom. 4 plus 11 plus 3 plus 6 is going to equal 24. And then we want to know how many, we're looking for the probability of picking a pair of diamonds. So that's going to be the favorable outcomes at the top. So how many do we have with diamonds? We have 11 plus 6. Okay, so our answer is C. 17 out of 24 is going to be our probability. 3 6-sided dice are rolled. What is the probability that the dice are showing 1 out of 6? So each dice that is rolled, the probability of it showing a 6 is going to be 1 out of 6. And if we are doing 3 of them, we're just going to multiply them all times each other. Probability of the first dice throwing a 6 is 1 out of 6. Probability of the second is 1 out of 6. Probability of the third is 1 out of 6. So you multiply them all together, and you get 1 out of 216, I believe is the answer. Yes. Okay, the next one, the following balls are placed in an urn: 4 red, 5 yellow, 3 blue, and 5 green. One ball is randomly drawn from the urn. What is the probability that the ball is either yellow or green? So the number of possible outcomes is adding them all up. 4 plus 5 plus 3 plus 5 is going to give you 17. And now we need to know yellow or green. There are 5 yellow and 10 green. 5 yellow and 5 green, so that's 10. So our answer is 10 out of 17 is our probability of drawing either a yellow or a green. Pete places chips in a box labeled 1 to 23. Pete has 115 people randomly select a chip from 1 to 23. How many people would you expect to draw the number 15 chip? That's 1 chip out of 23 chips, and times 115 people is how you'd figure that out. So 1 out of 23 times 115 people gives you 5 people. Okay, the next one's a little tricky. A stack of cards contains 5 hearts numbered 1 through 5 and 7 clubs numbered 1 through 7. If 2 cards are drawn at random with replacement, what is the probability of drawing a 2 of any suit on the first draw and exactly the same card on the second draw? So the probability of drawing the 2 of any suit and then drawing the same card the second time. I think that a good explanation down here. So drawing a 2 would be 2 cards out of 12 cards, because there's a 2 in the hearts and a 2 in the whatever the other suit was. So 2 out of 12, which comes to be 1 out of 6. And then the probability of drawing the same card would just be 1 out of 12. Okay, and this is the A and B lesson that they were talking about, so we need to multiply them. 1 over 6 times 1 over 12 is 1 over 72. There's so many ways to do probabilities, so it's kind of hard to teach you. You kind of just have to, these are one of the things you kind of got to practice and see and take your best guess, because there's lots of different scenarios and things to think about. The next one, at Southwest High School, there is a vending machine on the second floor that is broken, so the students never know what kind of drink they'll receive. Of the first 41 students to use the vending machine, 14 received lemon lime drinks and 11 received cola drinks. Susie purchases a drink from the vending machine. Based on this information, what is the probability that her drink is neither lemon lime nor cola? So we need to find the probability of it being lemon lime or cola and then subtracting that. Okay, so we had 14, so 25 out of 41 kids got lemon lime or cola. So 41 minus 25 is going to give us everything else. So the probability of her getting something other than lemon lime or cola is 16 out of 41. Okay, a class of 25 students is having a drawing. Each student's name is placed on a piece of paper, then placed in a hat. One name is randomly drawn from the hat. If there are 9 boys in the class, what is the probability that a name drawn is a girl's? So 9 out of 25 is the probability for a boy. So 25 minus 9 means there's 16 girls in the class. So 16 out of 25 have the probability of it being a girl. Now these numbers here is just doing 16 divided by 25. Okay, 0.64. There's also a 64% chance that it will be a girl's name that is drawn from the hat. That's what all these mean. They're just these fractions as decimals, so don't let them confuse you. The following chips are placed in a bucket: 1 red, 4 yellow, 5 blue, and 5 green. One chip is randomly selected from the bucket. I'm tired. I can't talk, I guess. What is the probability that the chip is either green or yellow? Okay, so we add all our chips together, 5, 10, 15. We have 15 chips. We're picking one out of the bucket, and we want it to either be green or yellow. So the possible outcomes is 15. And they're green and yellow, they're 9 green and yellow, so 9 out of 15 is your probability of picking a green or yellow chip. Okay, instead of having sick time, Klein Manufacturing offers personal time to their employees. An employee can have up to 5 days of personal time a year before they start using their vacation time for illnesses. Any unused personal time is treated as vacation time for the following year. Employee records of the past year are presented below. So we have the number of employees and how many days they have taken in personal time. If an employee is selected at random, what is the probability that over the past year, the employee took 4 personal days? Then we want to add up all of our employees: 4 plus 2 plus 4 plus 4 plus 4 plus 3, 21 students or 21 employees, and the probability that they took 4 personal days. There's only 4, so it'd be 4 out of 21, or B. Okay, these might be tricky. I'm going to be completely honest. So there's just so many possible scenarios. The best way is just kind of to practice them. So if you're really struggling this, we can find some more worksheets and do some more at Sunny Island and practice these some more. So don't get stressed or upset. It'll be okay. So I hope this video was at least somewhat helpful to kind of think you of different ways that you can solve these. Let me know if you have any questions.